Today's lesson is 7.8.2 Synthetic Division. When you divide a polynomial by linear factors such as x minus r1, you can use a shortcut method called synthetic division. Synthetic division is simply an abbreviated form of long division. This is telling us an initial condition where before we can use synthetic division, we must check that what we are dividing by is a linear factor. This is the same as a degree 1 polynomial. Now let's do an example. In this example, I started out by doing it using long division. So I have my numerator under the division symbol, my denominator on the outside, and I begin to divide. So I need to see how many times x goes into 6x cubed. Well, that's 6x squared. My next step is 6x squared multiplied by x gives me 6x cubed. 6x squared multiplied by 2. I need to add 12x squared onto that. Now what I do is subtract this entire quantity away. 6x cubed minus 6x cubed, 0. 11x squared minus 12x squared, negative 1. Then bring down the negative 17x and the negative 30. Now I need x to look like negative 1x squared. I do that by multiplying x by negative 1x. My next step here, negative 1 times x gives me negative 1x squared. Negative 1 times positive 2, negative 2x. And now I subtract away this quantity. Negative 1x squared minus negative 1x squared gives me 0. Negative 17x minus negative 2x gives me 15. Now I need to make x look like negative 15x. Well, all I only need to do then is multiply by 15. So negative 15 times x, negative 15x, this one. Then negative 15 times positive 2 gives me negative 30. And now I just need to subtract away this entire quantity. And that leaves me with 0. So I have a remainder of 0. That means both 6x squared minus 1x minus 15 and x plus 2 are both in fact factors of 6x cubed plus 11x squared minus 17x minus 30. Now, I would like to start with synthetic division. Before I can even reveal synthetic division, I need to check my initial condition. Is the number I'm dividing by a degree 1 polynomial? That is, there's only an x to the first in it, so in fact, x plus 2 is a degree 1 polynomial. Now, as I look in synthetic division, I have this negative 2. I found this negative 2 by looking at this positive up here and taking the opposite of it. So the opposite of positive 2 is negative 2. Now the next step here is to write out the coefficients of the number that we are dividing. In this case, it is 6x cubed, and I can see that here, 11x squared, negative 17x, and a constant of 30. After I have these numbers written out, I can begin to do my math. The first thing I must do, bring down the 6. The next step here is to take negative 2 times 6, and that equals negative 12. Now I'll look at 11 plus negative 12, and that is equal to negative 1. So now I will take negative 2, multiply it by that negative 1, and that equals 2. Negative 17 plus 2 is equal to negative 15. Next, I'll take negative 15 multiply it by -2, and that gives me positive 30. And simply -30 plus 30 equals 0. So now I have this 6, this -1, this -15, and this 0. The first number I'd like to talk about here is this 0. In synthetic division, the number farthest to the right is going to be our remainder. And because we did this in long division, we can also clearly see our remainder is 0. Now, when we look at the other three numbers, we need to look back to the original polynomial. So 6x cubed plus 11x minus 17x. Well, I see here my highest power is x cubed. And since I'm dividing away an x, the highest power I can have in the polynomial that I'm finding through division is x squared. So I'm going to write here 6x squared. Then I need to continue treating each number here as the coefficient corresponding to that x term. So minus 1x minus 15, which is the constant. And as we see down here, that is what we need to do. Now, for this next example, we're using synthetic division to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. So my first step is to look at this x plus 3. Is it a first degree polynomial? Well, yes, in fact it is. So I can proceed with synthetic division. I need to look at my plus 3 term then. In the box here, I can write the opposite of it, which is negative 3. Now I need to list the coefficients in the numerator. So my x to the fourth coefficient is 1. Now when I'm reading x to the fourth minus 10x squared minus 2x plus 4, there is no x to the third term. Well, there is actually one stuck right in here. We just can't see it because it is 0x to the third, which in fact equals 0. So when we're writing the coefficients, we still need to write the coefficient to the x cubed term. My coefficient to the x squared term is negative 10. To the x term is simply negative 2. And to my constant is 4. Next thing I'm going to do here, draw the line and begin using synthetic division. So I'm going to bring down my 1, then negative 3 multiplied by that 1 gives me negative 3. Well, 0 plus negative 3 is still negative 3. My next step, negative 3 multiplied by negative 3. Well, that's going to give me a positive 9. Negative 10 plus positive 9, that's going to give me negative 1. So negative 1 multiplied by negative 3, that's just 3. Negative 2 plus 3, 1. So now negative 3 multiplied by 1 is going to give me negative 3. 4 plus negative 3, 1. So right off the bat, I see I have a remainder of 1. Now let us write this in the form of our final answer. So I see up at the top right here, I started with x to the fourth. So my leading power of x as I'm writing, my final answer is going to be x cubed. I will have x cubed, 1x cubed, minus 3x squared minus 1x plus 1, and I will have a remainder of 1 over my initial denominator, which was x plus 3. And this is my final answer.